All right, I'm skipping to number 12 because number 11 we did in our jigsaw. All right, so diagram shows part of the curve. By the way, I took off the questions that have to do with the graph. So all you had to do on this problem is ignore the graph and just find your derivatives. So they want us to show that the derivative of this equals this. So looking at this, it looks like I have two functions. I have e to the 2x times cosine of x. So that means I'm going to use the product rule. So this is going to be a product. So my u is going to be equal to e 2 to the x, and my v is going to be equal to cosine x. I'll do the easy one first. The derivative of cosine is negative sine. Now this one is a little tricky because I have something going on in my exponent. So I have to use the chain rule on this. So I'm going to call w is going to be my 2x. So u is equal to e to the w. So then w prime, the derivative of the exponent, is 2. And then the derivative here would be just e to the w, because the derivative of an exponential function, of a natural exponential function, is just the same thing. Then I multiply these together. So my total derivative is equal to 2 times e to the w, which was 2x. Okay, so the derivative of this is this. Okay, I've got to keep track of these because we are going to be using the product rule. All right, so here's my u, here's my v, here's my derivative of v, here's my derivative of u. Now we crisscross applesauce. Yeah. So it doesn't matter which one goes first because I'm just going to be adding them. So I'll go ahead and start with, I don't know, let's start with this one. So I have dy dx. Oh, I forgot. I want it to look like this, right? So yeah, I want to start with the one that has e. Okay, it's not going to look like it right away. We're going to have to do something here. Times cosine x, so this one times that one, plus this one times this one. So e to the 2x times negative sine x. Now, how did they get this to look like that? Notice they pulled out the e to the 2x, because e to the 2x is in both of these. So I'm going to pull that out. I'm going to factor that out. So if I factor out my e to the 2x, I'm going to be left with 2 cosine x plus negative sine x. And instead of writing plus a minus, I could just change it to minus. So I'll erase those and just change it to minus. And there it is. I had to factor out the e to the 2x. Now I want to take the second derivative. So I'm going to start with this, and I'm going to take the derivative again. So again, I have two things being multiplied together. I have e to the 2x being multiplied by all of this. So my u is going to be e to the 2x. And we already know what that derivative is. We did all that work up here, so I'm just going to borrow it to e to the 2x. Okay, so this first part is my u. The derivative I already know because I did it before. Now my v is going to be all of this, so that is 2 cosine x minus sine x. Okay, and then we can just take the derivative in parts. When you have stuff being added together, or subtracted, because subtraction is basically the same as adding, it's just adding the opposite, I can just do these in parts. So v prime, I'm going to take 2 times cosine x. We just keep our constant like we always do our coefficient, keep our coefficient, and then times it by the derivative of cosine, which is negative sine. Okay, so that's this is the derivative of 2 cosine x. Then I'm going to take the derivative of sine x, so here's my minus sine. The derivative of sine is cosine. And now this is, did I do that? Yeah, okay. So now we're going to use the product rule, because I've got two functions being multiplied together, so crisscross applesauce again. And notice we're trying to get e to the 2x in front, so I'm going to start with that. So I'm going to start with this one times that one. So I get d2y over dx squared is equal to 2 e to the 2x times all of this, 2 cosine x minus sine x, plus, now the other one, e to the 2x times all of this, 2 times negative sine x minus cosine x. Okay, so notice I can factor out, and factor this out, and factor that out. See how I have 2 terms here? And see how I have this times parentheses, this times parentheses? Those are both the same, so I can factor them out. E to the 2x. So what's left behind? 2 times 2 cosine x minus sine x plus, okay, see this is now gone. I've factored that out. I've factored it out. It's over here. So what's left? Parentheses, 2 times negative sine x. I'm going to go ahead and simplify that. I hope that's okay with everybody. 2 times negative sine x is negative 2 sine x minus cosine x. Okay, and now I'm going to distribute this. Oh, I'm running out of room. Oh, check this one out. Didn't we already do that one? Did we do that one in class? No, we did one really similar to it, though. We did x squared over natural log x. Okay, so I guess I'm going to have to do that one. All right, I'm running out of room. Let's get out the scratch paper. All right, so I'm going to simplify this. I write too big. Sorry about that. So I still have my e to the 2x. I got to keep simplifying because I got to get it down to here. So I'm going to distribute this 2. So I get 4 cosine x minus 2 sine x. That's this part. So that gets rid of my parentheses. When I distribute, I can drop my parentheses. Plus, here it's just like basically a 1. So distribute my 1. So negative 2 sine x minus cosine x. Drop my parentheses. Now I can combine like terms. 4 cosine x minus cosine x. So I have e to the 2x. 4 cosines minus a cosine gives me 3 cosines. And then my sines with my sines. Negative 2 plus negative 2 is negative 4 sine x. Did I get it right? Oh, I forgot. Remember I told you there was a typo on this. That is sine. That was a typo. I was like, starting to panic right there. That should have been sine. There was a typo on that one. So there it is. That's number 12.